Good morning, YouTubers, philosophers. I'm going to talk about how you could make a mark in philosophy worlds. Philosophy world being a big place with lots of professors and lots of lay people outside the four walls of academia, such as myself at this time. But I do wander into Reed College and occasionally teach a middle school class, so we're talking philosophy for children in a lot of ways, called Martian math. I've only done that twice, and then I'll teach Martian math, what I call Martian math, on YouTube. Like here, you'll find quite a few of these videos on this topic. And it's really just my umbrella term for, well, it's two things. It's one of four maths that I put together in sort of a digital math curriculum. So I can look that up anytime I want in New Zealand at the Wiki Educator server. And their Martian math is contextualized as one of four topics in math. It's a very idiosyncratic, you could say quirky breakdown, but it has a logic to it in that it's got a timeline from the past to the future. One thing I find deficient even in the internet culture that we live in is how few timelines there are. In other words, if you go to timelines.com expecting some wonderful app where you can just scroll through timelines and jump around and see who talked to who, and you don't get that. And I can't find anywhere on the internet where I can get that at this point. It's not so much Ancestry.com that I'm looking for. It's not like everyone in the world. It's let's just start with some people and then gradually add to it. I don't know. I'm just suggesting we could do better. So Martian math looks towards the future, and Neolithic math, of course, looks towards the past. So that's the time axis. And then sort of flanking the time axis, like you could say two wings that fly along this arrow of time, we have the problem of distributing, like economics, you could almost call it, but I call it supermarket math. And there's, that's a huge topic. You've got e-commerce, databases, things that we don't normally touch in math because we have all kinds of cultural biases. Now that computer science has come along and crammed itself into a science, and math is not science and all this, I mean, what is going on? STEM. So that's enough preamble about Martian math in that sense. It's just casino math is the other one. That's risk, probability, judgment. What is the smart way to go into the future? So if you're on a timeline from the past to the future, we're in a position where we have to exercise judgment. By we, I mean in our daily lives, and then as organizations, as institutions, we have meetings. There's a steering function. We're planners as well. So, and we draw on our futuristic skills too, as the Martian math delivers. Now, the other thing I do with Martian math really is I use it to take in what Fuller developed, Buckminster Fuller, in his lifetime, which was an interesting, I would say, maverick or contrarian math. And there was a philosophy professor I was watching yesterday on YouTube who said, he quoted a passage from this book. I believe it was from this book. It might have been from one of his other notebooks, Wittgenstein. Very famous philosopher, still obscure though, because philosophy as a whole has become quite obscure. But he said, what if set theory had been done as kind of satire, but then people realized as they were reading it that there was something to it, and actually it was mathematical. So he was kind of saying, could a math start out as satire? And actually I think we have a real instance of that in the case of Edwin Abbott's Flatland. This book is really cited a lot, and it's about how we can experientially really feel what it's like to be one, two, and of course three-dimensional beings. It's written as kind of their characters and so on in this book. And of course, they don't understand four dimensions. And so this book is cited all the time in mathematical literature as, sort of a mind, a headspace to get in when you're thinking about dimension. And yet it was written, as my understanding, as political satire. And so that's interesting. I would say you could say something similar then about quadrats. So here we go, looking at Martian Volume. This is not a linear algebra system that you're going to see in linear algebra with four basis vectors to these four tuple corners, the linear combinations of which map to all the points. So there is an XYZ to IVM, I'll call it, isotropic vector matrix. What Fuller called his coordinates skeleton, we'll not call it a coordinate system off the bat. An IVM is a scaffolding, a skeleton, a repeating tessellation, or voxelization of space, just like XYZ is all cubes packed together. The IVM is tetrahedrons and octahedrons packed together. But they're not just any tetrahedron, octahedron, they're the regular ones, and actually there's a volume ratio, a nice one, of 1 to 4 between the tetrahedron and octahedron. And with nice volumes like that, you're thinking, gosh, why should we spoil everything with the cube coming along and having an irrational volume somehow? But we don't have to do that. We can have the cube, and we can have the cube be volume 3. So there's a wonderful sort of hierarchy of volumes that we should be allowed to enjoy, that the Greeks could have stumbled on, that anyone in Western civilization or Eastern civilization might have developed but didn't, where the tetrahedron is our unit of volume. But Fuller goes further than that. He's not, if he'd just written that paper and published it in an obscure journal, I think he could have made his living as a math professor, or a philosopher of some merit. But he was very, architectural. He went into the geodesic domes. He didn't get around to the synergetics. Without the help of Applewhite, he wouldn't have probably gotten it at all. Until towards the end of his life, it finally came out. And it was somewhat dismissed as wordy and clearly not a math book, so who's going to read it? Not a philosophy book, because he doesn't cite doesn't talk about Quine or even Wittgenstein. Now that we have a next couple generations of philosophers coming along, these characters all do get put in the same index. In other words, we do have philosophy books now, and I'm not talking about my writing in particular, but mine included, that does bring these characters together. But what I'm suggesting is that you follow Fuller in seriousness in questioning, where did this dogma come that we live in a three-dimensional world? We always say height, width, depth, but if you think about it, if you're already thinking of a box or even an individual line, where are you relative to that? Don't you have a viewpoint? And isn't it necessary for anyone to have awareness, for there to be a subjective experience of what Descartes called res extensa? Don't you have to have volume right off the bat? Isn't it always volumetric? Whatever dimension volume is, that's where we live in terms of thinking and imagining. Now you could say time is always in the picture, and I'm open to that idea, but when we want to talk about how many dimensions does pure space have, why do we have to say 3? Are we compelled? Has that been proved? Is it axiomatic? What other civilizations came up with it? Did Kant see in the mind's eye that the world is a priori three-dimensional? Or is this something that in school is kind of told to us as a dogma, and could we ever fight it? And I think Fuller, as a maverick, did fight it, and I think he put up the best fight of anybody that I know in the literature. Like, if you wanted space to be 4D, 4-directional, 4-dimensional, he's got a good argument for that. It's always volumetric, even points. Like, you could say points have no part. Well, points, we don't care about their parts. Whether they have them or not, I think would be a good way to put it. Euclidean, It's non-Euclidean if you like, no matter how you can zoom in on a point and it will become a sphere or something, a blob. In other words, we think of our items in space as all having the same dimension. And Carl Menger was kind of going this direction in one of his essays, a dimension theorist. We can have long, thin things, and we can have little pointy things, and we can have boxes, and we can have sculptures. We can have any shapes we want, but if they're just ordinary volumetric shapes that take up space in some way, then let's just call them lumps. And then all lumps are then, well, we would say early in our training, we'd say all lumps are 3D, like points occupy volume, even if it's minuscule and we don't care about how much. It's just a position, fine, but position itself within what accuracy? So there's always room for wiggle. The precision is not infinite. It's a discrete math, and it's approximate in the sense that precision is not infinite. So there's always volume, there's always that, and then what is the dimension of volume? Well, we say 4D because it's tetrahedron. Primitively, it has 4 dimensions. It has 4 directions, you could say. Like a cube is more complex, and people say, well, X, Y, Z, we only need 3 coordinates, but you also need negative numbers. You need 6 vectors. You need your negative of the basis vectors. A caltrop of 4 radial members is less busy than a jack of 6. So I think here is where to make your stand in philosophy and question, not replace one dogma with another, but understand the nature of mathematical definitions more deeply as cultural and not necessarily cast in stone the way we think space is 3D has to be. Space could be 4D in a different high-tech civilization, one that's equal or better to ours. So that's why I call it Martian, because maybe the ETs think this way. Anyway, give it some thought. I think you could be in on the ground floor with lectures of that nature. I don't necessarily need to be the only one doing this, is what I'm saying. There's lots of room in the swimming pool. It feels kind of empty, but water's fine. Talk to you soon.